Today we are going to learn how to name ternary ionic compounds. You will need a periodic table with the charges of the ions labeled. You will need your reference table. Turn to the very last page at the bottom, and there is a list of polyatomic ions that you'll need to use. Also, get your ions cards that we used the other day. When you have a ternary ionic compound, ternary means there are at least 3 different elements in the compound. Yesterday we learned how to name binary ionic compounds with 2 different elements in the compound. Ionic compounds, remember, have a positive and a negative ion. So they are usually made from a metal and a nonmetal. So let's take a look at how to write the formula of aluminum phosphate. First, we need to find aluminum on the periodic table. Remember, the first ion is always positive, so you just need to look through these 2 groups or aluminum for the positive ions. Oh, well, there's aluminum. So let's write down aluminum has a positive 3. Then the phosphate ion. Now be careful. These ions end in "ide," so this is the phosphide ion. Your paper asked for the phosphate. If it ends in 8, it's one of these polyatomic ions. And here is the phosphate ion. The formula is PO4 -3. So PO4, you always say the subscripts first because we have 1 phosphorus and 4 oxygens. That's what PO4 means. Then you say the charge -3. Because this -3 doesn't just go on the oxygens, it goes on the phosphorus too. It goes on the whole entire ion. So, if aluminum has a positive 3, we need to get the positive 3 cards. And phosphate with a -3, the -3 cards. Oh, we need 1 aluminum and 1 phosphate. So the formula is Al. We just need a single aluminum, and then we need a single phosphate. Phosphate is PO4. The charges have canceled, but we need 1 PO4 ion. Make sure that's a capital P and a capital O, because if it's this way, a capital P is phosphorus and a capital O is oxygen. But if you put a capital P and a lowercase o, you're trying to say polonium. So it's really important that you put the correct capital or lowercase letter. Aluminum is capital A lowercase l to say, hey, this is all 1 element. All right, now what if we had done the crisscross rule instead? The positive 3 and -3, a 3-to-3 ratio reduces down to a 1-to-1 ratio. Then we crisscross the numbers. The 1 from aluminum goes after the phosphate and you don't write a 1. And the 1 from the phosphate goes after the aluminum and you don't write a 1. So you get the same answer either way. Let's take a look at potassium nitrate. Pause this video and look up potassium on the periodic table and nitrate on the ions list. Okay, so you found that potassium is K plus 1, and nitrate is NO3 minus 1. Potassium is found here. That's how you know it has a positive 1. And nitrate is found on your polyatomic ion list. Remember, it's NO3, 1 nitrogen and 3 oxygens, and the whole thing has a charge of -1. Okay, so we get a positive 1 and a -1 card, and it's the perfect match. We need 1 of each, 1 potassium, 1 nitrate. So we write 1 potassium, K, and we write 1 nitrate, NO3. What if you were doing the crisscross rule? You have a positive 1 and a -1, so the 1 crosses after the K, and the other invisible 1 crosses after the NO3. So don't write your invisible ones. You take a moment and try calcium carbonate. Pause this video. So calcium has a positive 2 charge, and carbonate has a -2 charge. It takes 1 calcium ion and 1 carbonate ion to make calcium carbonate. So we write a single calcium and carbonate is CO3, so we write a single carbonate. If you're doing the crisscross rule, a 2-to-2 ratio will cancel. Then you copy the calcium, put the invisible one, okay, you don't put it, and copy the carbonate, CO3, and put the invisible one after it. All right, so we have something a little bit different here. You only use parentheses around more than one of a polyatomic ion. So if you just have one of an ion, you don't use parentheses. You have to have 2, 3, something like that. If you have a polyatomic ion, now what's that? Well, poly is a prefix meaning many. The way I remember what polyatomic means is that I think I have this Polly the parrot sitting on my shoulder here, and she says, Polly wants many crackers. And poly means many. So polyatomic ions have many atoms, more than one atom. And so these are all polyatomic ions because, for example, ammonium has 1 nitrogen and 4 hydrogens, so it has 2 types of elements. Acetate has 3 different elements, 2 carbons, 3 hydrogens, and 2 oxygens. You get the idea. So all of these polyatomic ions have more than one different atom in the ion. Now let's take a look at magnesium hydroxide. Pause just for a minute, look up the magnesium ion and the hydroxide ion, then continue this video. So you will notice that magnesium has a positive 2 and hydroxide has a negative 1. If we are doing this with the cards, you have a positive 2 card for the magnesium and you have a negative 1 card for the hydroxide. So when you make your compound, you need 1 magnesium and 2 of these hydroxides. So we write down a single magnesium and we write down 2 of the hydroxides. But wait a minute, hydroxide is a polyatomic ion. It has both oxygen and hydrogen. And we're going to need 2 of these hydroxides. We're going to need more than 1 of this polyatomic ion. So you'll need parentheses around the hydroxide with the 2 outside. What this means is we have 1 magnesium and a hydroxide and another hydroxide. Or if you prefer, you could say 1 magnesium, 2 oxygens, and 2 hydrogens. But nobody ever writes it that way because how are you supposed to recognize the hydroxide ion? When it's written like that, I'm not going to be able to pick that out of this list here. I'm going to be confused. So you leave the ion together and put it in parentheses and say, I need 2 of the O and the H. If we were doing the crisscross rule, you would take the 2 off of here and put it as the subscript after the OH. You'd take the 1 off of here and crisscross it here. Remember, leave off the charges. So an invisible 1 is after the magnesium, and a 2 is after the OH. Once again, you just have to remember, there is more than 1 of this polyatomic ion. There's going to be 2 of these hydroxides. So that's when we need parentheses. All right, you try sodium phosphate. Pause the video and try it now. So sodium has a positive 1, phosphate has a negative 3, and the 1 and the 3 don't cancel, so we just crisscross them. So Na3. Now, do we need parentheses? Well, we do have more than 1, but is it a polyatomic ion? No, it's just 1 atom, just sodium. There are no other elements there. So we do not use parentheses. Then we have a phosphate ion. We're only going to need 1 of them. Do we need parentheses? No, we only need 1 of this polyatomic ion, so we do not need parentheses. So simply copy down all the letters and the subscripts. You try barium hydroxide. Pause the video. Barium has a positive 2, hydroxide has a negative 1. So the 1 after the hydroxide goes here, and the 2 from the barium goes here. So we copy down barium, we just need 1. We copy down hydroxide, we need 2 of them. Ooh, We need 2 of this polyatomic hydroxide, so don't forget the parentheses. Pause the video again and try potassium sulfate. The crisscross rule says that we're going to have 2 potassiums. We don't need parentheses because it's only one type of atom. Then sulfate, SO4, copy all of your subscripts, and the invisible 1 after the potassium goes here, so if you have an invisible 1, you don't need parentheses. Oh, I forgot to put the 2 after the K. Pause the video and try barium chlorate. When we do the crisscross rule, the 1 goes after barium, so we just need a single barium. The 2 goes after the chlorate. Now wait a minute, we have a 2 and we have a 3. What do? You copy all of your subscripts, ClO3, then the 2 goes outside the parentheses because we have more than 1 of this polyatomic chlorate. Ammonium nitrate, try that one. What's weird about this is that both ammonium and nitrate are polyatomic ions. You won't find ammonium on the periodic table. When you crisscross, the 1 and the 1 will both be invisible. So, copy your first ion, NH4, copy all your subscripts, and the invisible 1, okay, so we don't write it, copy your second ion, NO3, and your invisible 1, so you don't write that either, and you're done. You try beryllium nitrate. All right, so copy your beryllium and crisscross the invisible 1, copy your nitrate, and crisscross the 2. We're going to have 2 of this polyatomic ion, so we need parentheses and then a 2. Try sodium acetate. Pause the video. We have sodium with a positive 1 and acetate with a negative 1, so the 1s will cancel. So you simply copy down sodium, then copy down the entire acetate ion, C2H3O2. You have invisible 1s, so you're done. Pause the video and try magnesium sulfate. Okay, we have a positive 2 and a negative 2. They cancel. So that reduces to a 1-to-1 ratio, so the 1s are invisible. Copy your magnesium, invisible 1. Copy your sulfate, invisible 1. Strontium acetate. Okay, so we have a positive 2 and a negative 1. Copy your strontium, invisible 1. Copy your acetate, C2H3O2, and this 2 goes after the entire polyatomic ion, so we need parentheses and an extra 2. Now let's take a look at how to name ternary ionic compounds. This is so much easier. The first element is almost always the first ion. Everything after that is the second ion, no matter how many atoms you have left. Unless NH4, ammonium, is your first ion, then that's a polyatomic ion at the front. That's the only polyatomic ion that you will find at the beginning of a compound. So either NH4 or your first element is the first ion. So we have lithium. That is the first element, so we just write lithium. Everything that's left is the second ion. If there are no parentheses, the number is included. So CO3. We find CO3 on our polyatomic ions list because it had a C and a O, capital C and a capital O, and that is carbonate. So we write lithium carbonate. The next one, Al, is the first element. We look on the periodic table, that is aluminum. So we simply write aluminum. Then OH, notice the 3 is outside the parentheses, so it's not part of the ion, so we look for OH. It's polyatomic because there is both an O and an H. There it is, hydroxide. So this is aluminum hydroxide. Let's skip down to number 18. Notice there's an NH4 at the beginning. So ammonium is the first word. Then everything after ammonium is the second ion. So the C2H3O2 is all the second ion. Don't break it up into more than one. There can only be two ions, a positive ion and a negative ion in each compound. There it is, acetate. So this is ammonium acetate. Don't forget to go back and do 16 and 17 and then finish the rest of your worksheet.